Assalamualaikum warahmatullahi wabarakatuh to Dr. Shazra. First of all, I would like to say sorry because I have trouble with my camera. So first of all, I would like to say a thank you for giving me the opportunity to present in front of you. So and thank you for guiding me throughout this semester. So without wasting time, I will explain to you the effect of I will present to you the effect of nanoparticle and sweetening surfactant on enhanced oil recovery. So this is my table of content. So there are four component in table of content, which is the first one is the introduction, the second one is a literature review, and the third one is research methodology, and the fourth and is expected result. So right, there are four major component in my research, which is UR, chemical flooding, nanotechnology, and the last one is a pattern. So right, UR is defined as a process that extracting oil that has not been recovered by first and secondary method. It also known as tertiary recovery. The next one is chemical flooding. So chemical flooding, what is chemical flooding? Chemical flooding is a generator that we use chemical composition by injecting into the reservoir to increase the production of oil. So what example of chemical flooding? So we will use, for example, we use the alkaline and polymer. So the next one is a nanotechnology. Nanotechnology is defined as a smallest particle that has less than 100 nanometer, which is aluminum oxide, zirconium oxide, silica oxide, and so on. So the last one is surfactant. Surfactant, what is a surfactant? Surfactant is act as a stabilizer or enhancing agent to increase the amount of oil recovered. So for example of the surfactant, we have a SDS as an ionic surfactant, and detergent is a surfactant too, and so on. So next is this is an example of an injection well. In an injection well, as we can see here, it use a surfactant to increase oil production. So the surfactant flooding will be occur and will increase the oil production. So next one is my scope of study. So there are five components that are significant in my research, which is the first one, CPDB is derived from castor oil and used as a surfactant at 0.5%. The second one is a brine solution. It's prepared at 0.5, 2, and 4% concentrated. The third one is hydrophilic nanosilica, and CPDB is used in preparation of the nanofluid. And the fourth one is we will perform the panel drop test, spinning drop test, and sample flooding test. So the last one is a result analyzed for the wettability alteration, IFT reduction, and displacement efficiency. So all of these experiments will conduct at the same pH, temperature, and pressure. So the next one is my problem statement. So since the nanoparticle does not have a problem with low salinity, but it will find a challenge when it comes to high salinity reservoir condition due to the unstable condition that easily to react to clay mineral such as magnesium 2 plus and Ca2 plus. In this research, we will combine the high and low salinity price solution, surfactant, and nanoparticle in order to maximize the oil recovery. So the question is, does the presence of CPDB surfactant help nanoparticle to survive in high salinity? So my objective of my research is, the first one is to determine the impact of nanofluid at various concentration, at a various brine concentration on the IFT reduction and wettability alteration. So the second one is to study the performance of the nanofluid in high salinity of brine for enhanced oil recovery. So we move on to the next slide, which is a literature review. So as you can see here, I found a lot of information which include the wettability alteration mechanism and intervention mechanism. So I will focus on these two mechanisms based on my research. So additionally, I find the type of surfactant, which is there are four types of surfactant, which is anionic surfactant, cationic surfactant, non-ionic surfactant, and sweetened surfactant. The last one is I find to the I find the preparation of the nanofluid, how we prepare the nanofluid. So we move on to the next slide, which is the most important thing that that used in my research which is the first one is nanoparticle. So the nanoparticle has special ability in terms to improve IF3 reduction and velocity alteration. So the second one is glutamate surfactant is known as amphotericity surfactant, has positive and negative charge which can neutralize each other. The next one is salinity. Salinity is one of the factors that influence surfactant or extraction. High salinity water is not desirable for the anion surfactant due to it will perform the precipitate from the interaction salt ion and surfactant. So the nanoparticle cannot survive to high salinity due to high surface energy and easy to react with another substance. The second one is the displacement efficiency. So, concentrated nanoparticle will lead to the high displacement efficiency that will prevent the viscous fingering in pore space. So the next one is the interfacial tension. And what is an interfacial tension? Interfacial is defined as a force attraction between molecule at the interface of two fluid, for example, oil and water. Nanoparticle act as a carrier via Brownian motion that will transport surfactant into surface. So it will reduce the amount of the surfactant loss. And the last one is a vertebrate alteration. So, for the vertebrate alteration is the process that making reservoir rock more wet. This is because to allow the water to penetrate solid matrix rock. So it will produce more rock. So the next one is a methodology. So we'll start with a brine solution is prepared at 0.5 to 4% concentration. So next one is a nanofluid are prepared by depressing nanoparticle and CPDB surfactant in various brine solution. The next one is alcohol solution of nanofluid will be created at a 0.1, 0.5, 0.1, and 2%. Next, we will perform the spinning drop method to measure IFT. Contact angle of nanofluid are measured using spinning drop. And sample flooding is performed to test a displacement efficiency. And the last one, we will do the result analysis. So this is example of the how look the pen and drop, spinning drop, and sample flooding. And the last one is expected result. So as we can see here, for consolidated nanofluid, the contact angles for water decrease as salinity increase. So the next one is IFT graph. So for the IFT graph, the highest concentration of nanofluid will yield the lowest IFT reduction at high salinity. And the last one is oil recovery graph or recovery pattern. So this was proof that nanoparticle with certain factor will use the highest oil recovery at a high salinity. So I think that's all from me. Thank you.